Hello everyone and welcome back. So today we'll be talking about a new topic and it's called uh, causality and the notion of Ceteris. This is R, okay, Ceteris Paribus. Sorry, this is U. Okay, so we'll try to understand what is the importance of the assumption that we make of Ceteris Paribus while checking the causality between two variables. Okay, so we had talked about causality and correlation in the previous video. So today we'll be talking more about causality and the role of ceteris paribus in establishing causality, or how ceteris paribus or the assumption of ceteris paribus help in uh, better explanation of causality between two variables. uh, so ceteris paribus basically means uh, this thing basically means holding other factors as constant, right? So when we hold other factors that might affect a particular variable while trying to calculate the effect of a particular variable. So let me re-put this. So suppose we have y as a variable and we have x as a variable. Okay, so this y variable might be affected by a lot of other variables, but we want to check how x affects y. Okay, so y might be affected by a lot of other variables, but what we are concerned right now is the impact of x on y. Okay, so we have to check for this causality. Okay, so in order to check for this causality between x and y, we'll have to assume that other factors that might affect y have been held constant. Okay, in order to have a better understanding of the causality between x and y, right? So that is why this relation of causality, or this notion of ceteris paribus, is very important when it comes to causality. So, but before that, let's discuss one more topic, or one more idea. Okay, so let me just add a new page here. Okay, so so why is causality so important in econometrics? So causality as a concept is really important when it comes to econometrics, because eventually, well, we move ahead, we'll try to see and we'll try to observe that what we end up doing is we end up trying to calculate the effect of one variable on another variable, and this effect is explained by the idea of causality. So whatever x is whatever impact x is causing upon y, that is one of the very major key interest of the topic econometrics. Okay, so that is why this idea of causality becomes really important, because eventually we'll end up looking for relationships between two variables and why these relationships exist. So causality then becomes really important. So just for the sake of example, uh, s- let's talk about, suppose uh, the government plans to increase your educational expenditure. Okay, so we might be affected, we might be interested in calculating or checking the impact of increased educational expenditure, which is this, on uh, wage rate of the graduated students, right? So we try to check the impact of increased educational expenditure on the wage rate of graduated students. So we try to check here the causality, that whether increased educational expenditure is causing a rise or fall in the wage rate of the graduated students. Okay, so causality becomes really important, and yeah, it helps us check the relevance or validity of a policy measure, okay, that might have been launched by the government or any other institution. Okay, so while correlation might be suggestive, uh, causality helps us conclude conclude conclude. So if we have taken a measure, the causality would help us conclude that the measure that we have taken and the intent behind the measure was successful or not. Okay, so that is explained by causality. So, let's try to. Let's take another example and try to understand one more idea here. So suppose we have agricultural productivity and fertilizer used. So we have these two variables wherein one is agricultural productivity and the other is the amount of fertilizer used. Okay, so we are trying to check whether the agricultural productivity is affected by the amount of fertilizer used. Okay, so we can form a model here wherein your yield, that is representing your productivity, is a function of land quality or rainfall, pest control, fertilizer, etc. So there might be a lot of factors that might be affecting the amount of yield that you get from a particular area of land. So what we want to capture is the impact of fertilizer that is being used on a particular piece of land and how it affects the agricultural productivity. So we are trying to establish a causal relationship between the impact of fertilizer and agricultural productivity here. So, and through this estimation, we might be able to conclude that whether using more fertilizer leads to more agricultural productivity or better yield. Okay, so when we are trying to hold this relationship, or when we are trying to test this relationship, we will assume that other factors that might be affecting your productivity or yield are held constant. So your land quality is held constant, the amount of rainfall is assumed to be constant, the pest that might affect the productivity are assumed to be constant. So we are in a way compartmentalizing the effect of effect of different variables and choosing to look into the effect of our variable of interest. So when I hold all these other factors as fixed, so the only thing that I'm changing here is now the amount of fertilizer. So based on that change, my yield is also getting affected. So I'm able to calculate the impact of fertilizer change on the yield from a plot of land. So having fixed these other factors, okay, allows me to see the impact of the factor of my interest. Okay, if I if I'm not able to do this, if I'm not able to control other factors, okay, I might not be able to get the best possible results when it comes to estimating whether fertilizer quantity is affecting your yield or not. Okay, so that is the reason it's really important uh, that we use the notion of ceteris paribus while checking the effectiveness of one variable over another variable. So that is all for in this video. I'll see you in the next video. Thank you.